It's fine.
All right, so. Okay, let's ignore that. Okay, I'll put the answers up there. If you don't want to look, don't look, Jeff. Anybody disagree with that? Yeah.
Can I borrow Mr. That? Just you can. I was gonna say you can bring it. Just, excuse me for.
No problem. What am I supposed to do? No, you can't.
Yes. Okay, did I do something wrong?
Yeah. On the first question, shouldn't we exponent one?
Yes. Just check it. Check it. Yeah, and well, I'll tell you why I got that one wrong. Because the first mistake I made, as I was going rushing through it, when I factored out a 4 right here, I put a 4 right there. Because obviously when you take 4 out of 8, you get 4. Yeah. But, you know, of course, that's one of the problems. Teaching algebra 1, yeah, exactly. That's one of the problems. You say you take 4 out of 4. It sounds like take away, right? When you're first learning factoring, kids screw that up all the time. So I did it, and I had a 4 there, so which would have made that x minus 2, and that's what happened. Then I caught my mistake, and then went back and fixed it, but I forgot to fix that. So, yes, it is x minus 1 there. Thank you. Okay, so right here, that should be a 1. That should be a 1 right there. Okay? All right. And then on this one, I feel like we've done this one before for some reason. But anyway, this is one of those where the x squared and the y squared. Now, when it gets to identifying, when you talk about identifying hyperbolas, right, you can tell right away this is an ellipse. Right? If we had a problem where we had to identify right away, you got an x squared and a y squared. They're different, so it can't be a circle. The coefficients are different, and they're the same sum. And even if they're both negative, that would be an ellipse, because eventually that negative would divide out of it. Right away, you know this is a hyperbola. It's got an x squared and a y squared, and even if they're the same, doesn't matter, because one's positive, one's negative. Now, it turns out that which one's positive, which one's negative switches once you get it into standard form, because right here you got to divide by negative 12. Turns this one positive and this one negative, so I go ahead and flip them around when I write it. Okay, and that's important because this is your A. Remember, A is not the bigger one on a hyperbola, A is the first one. Okay, so which way you write it, you want the negative to be here. So it switches, but it's still a hyperbola. So just part of that identifying piece. Okay, we're going to do it. And okay, so put them in standard form, getting that. And when we look at the quiz, I want to talk about this where you have to take out a negative. We didn't have to take out a negative. That caught a few people on the quiz. So let's take a look at those. So we did pretty good, Caleb, but there's some things we can fix, I think, for tomorrow, hopefully. Some of the mistakes I'm guessing you'll look at and think, oh my God, you could have done better. Silly mistake, maybe, I don't know. It's easy to make, though. I'm done. All right, so all right, perfect time. All right, questions on the worksheet. Now, if you just want to check some answers, I'll have the answer sheet out here. I think some of you saw it already yesterday, maybe, or maybe you didn't, I don't know. So if you want to do that, we'll have some more time. You can check it out. If something comes to mind right away you want to do, now let's see, Chloe, you need one of these from yesterday.
Number 6.
Number 6.
Chapter 7.
What's the front? Not this one?
Is it the zoo one?
The zoo one? Entrance to a zoo is the shape of a parabola. Write an equation for the parabola if the origin is at the vertex. Okay, so in other words, they're saying that this would be the origin right here, and here's your parabola. Okay, so this is 32 across this way, and this is 8 down like so. Okay, so this would be a good time just to review the idea of a parabola, right? So first of all, since this goes down, what's that tell you the equation is going to look like? Which one's squared?
Oh, X.
Right? Yeah, just think of your normal basic parabola that goes up as y equals x squared. Right? Y equals x squared is a normal basic parabola. So an up or down one's always going to be an x squared. Okay? So this is y minus k equals 1 over 4p x minus h squared, right? That's your basic equation, okay? So we know the vertex, right? So that makes it easier, is 0, 0. So since the vertex is, they said that right the equation origin is at the vertex, okay? So what else do we need? What else do we need? P, right? We need P. And then we'll have the, oh, well, that's going to be squared. We need P, right? Once we know P, we'll have, right? So what information is there? What's the usual information that you need? What's the normal information we have that gives us P? Directrix or focus, right? Because P is the distance, and we'll review that here in a minute, from the directrix to, or from the vertex to the directrix, vertex to the focus, right? Well, they don't say anything about a focus or a directrix, right? So that's unfortunate. So what else could give us P if we knew what else? This is the part that messes us up sometimes, okay? What could I label any of the points that are along the parabola? X and Y, right? In all of our equations, the X and the Y represent the coordinates. I mean, we spent so much time talking about H and K as the coordinates of the center, and A, B, and C give us the vertices, and they give us the vertices, the foci. C helps us get the foci. So we know talk about all these letters, but the ones we rarely talk about are the X and the Y, right? X and Y are the points on the figure. On the ellipse, like somebody asked me on the quiz the other day if on the sketch, when we sketch the graph, if you had to draw the foci. I would say no. I mean, if it says sketch the ellipse, the foci are not part of the ellipse. They're a property, a characteristic of the ellipse, but they are not a part of the ellipse itself. Okay? Like the center of a circle. You know, if you're supposed to sketch the circle, yeah, you probably do put the center in there because that helps you, but you wouldn't have to. The center is not a part of the circle. X and Y are the points on the circle. Okay, well, I would suggest to you that we do know the coordinates of this point right here. What would be those coordinates right there? 16, comma, how much?
0.
No, this is 0, 0 right here. So it's 16 over, and it's 8 down, negative 8. And we could put those in where? For X and Y. So we can put a negative 8 in for Y. We can put a 16 in for X. And then we can solve for P. Okay? So 16 squared is what? 256. So we get negative 8 over 1 equals 256 over 4P. And then what we did on these problems was cross multiply kind of a thing. So we could take 256 equals negative 32P. So P would be, what's 256 if I have a negative 32? 8, negative 8. So P would be negative 8. So, looking at that, we would have Y equals, and if P is negative 8, that would be negative 1 over 32 X squared would be our equation. Which makes sense to be negative because it opens down, right? So we want that to be negative. Okay? There you go. Good. So, in a story problem situation or in a problem where it feels like they've given you some information that's kind of strange, because most of the time when we give you a semi-major axis, or we tell you what A or B is, or we give you the focus, which helps you get C, or we give you the radius, if it's a circle, you know, somehow, or like in a parabola, we get vertex focus, that helps you get P. If they tell you a point, if they don't give you any of that, but they tell you a point on the figure, remember that's X and Y. That's X and Y, and you can put them in for X and Y. Okay? All right. For example, in this problem right here, let's say they didn't tell you A, for whatever reason you didn't have no C. All you knew was a center, you knew this, I guess that's A. So they didn't tell you B, this was B squared, but if they told you a point on the hyperbola, you could put it in for X and Y, and then you'd have only one unknown. You'd have B squared down there, and you could solve all that for B squared, right? And so that could be a problem. Okay? Anything else? And remember, if it ever says use the discriminant, just ignore that part of it and just identify what it is. We're not messing around with it. I mean, it's just, you just don't need it, right, guy? I mean, that's a problem.
Number 6 on the other side.
6 on the other side. This one? What's it say? State what it is, and then graph it, and write it standard. Okay, so what is it right away, right off the bat? What is it? It's an ellipse. It's got an x squared and y squared. They're both positive, so that's rules out hyperbola. So it's got to be an ellipse. And since the 100 and the 25 are different, it's not going to be a circle, right? If they were the same, it'd be a circle, okay? And so let's just look at that. If they would have been the same, if you'd have, because right now we're going to divide everything by what? 400, right? But if this would have been 100x squared plus 100y squared equals 400, if it would have been that, hopefully you look at that and say, oh wait, that's a circle. Now what would we divide everything by? We would divide everything by 100, right, if it was this, and then that would give you x squared plus y squared equals 4, and now you'd know the radius is 2, and you would be centered at the origin, right? So identifying whether it's a circle or ellipse is a good idea just for the fact that it kind of helps you, what's my next step to get it in standard form. But here we're going to divide by 400, so we can get a 1 over there, so that's going to reduce to an x squared over 4. That's going to reduce to what's 25 goes into there, what, 16 times? And then equals 1. So we're centered at 0, 0. Again, we said it was an ellipse. A is the bigger one, but it doesn't, I mean, it does matter. If we had to do the focus or something, it would matter. For graphing it, it doesn't really matter. So I think that's where some of you got in trouble on number 1 on the quiz, is you were worried about what A and B were. For graphing it, you don't need that. Now, to get the foci, you do, because you got to know which one's A, which one's B, so you can get C. All right, but for graphing it, you can just look at this and say, okay, this one's going to be 2, the square root. Okay, it turns out it's B. B is 2. But you say, well, that's going to be 2. I'm going to go 2 on the x, because it's under the x. And this one's going to be 4 along the y. So I'm going to go 4 along the y. Now, again, that is A, and that is B, so it's good to know that. You may need to know it, but for this problem, you really didn't need to know. It didn't really matter which one's A and B. It's just the one under here is going to go on the y, the one under here is going to go on the x. There's your ellipse. Oh, and then I did not take off any points on how good of a drawing for some of you is. But I felt like I really could when you look at my drawings. I have not set a good example. All right. And I've had years of practice. All right. Somebody asked about the XY when it comes to identifying these. The XY, all that does with the conic section is it makes it a rotated conic. Okay? So all of the rules we talked about, whether it's going to be an ellipse or hyperbola or parabola or circle, whatever, still apply. But if there's an XY term in there, it's going to be a rotated. We're not getting into the angle of rotation in that. So for our purposes, a problem like this, you can pretty much ignore the XY part of it. Okay. Now we do a little work with that in calculus, with the XY term, but okay. So just understand that's what it represents. All right, let's and I'll have the answers up here if you want to look that over some more. And I've got a sheet we're going to do, and then I've got a second one. If you want to take it, just an optional review sheet is fine, and we'll work on. If you rather think you're pretty good with it, and you just want to do the one while we're during class time, and then work on Excel, we do that too. Okay, but let's just go through a couple things here. I have no intention that you write all this down. I'm not sure it's even worth it. I can put it up here if you want to take a picture of it later or whatever. I've just kind of written down some things, okay, just to summarize all of our stuff about conics. So that's basically your general form of any conic, okay? A circle would be when A and C are equal, but they're not 0, right? If they were 0, if you didn't have a squared term, if you didn't have a y squared or an x squared term, that's when you get into the lines or something like that, right? What we call the degenerate conics, okay? We're not going to worry about those right now, okay? So we just assume that we have at least something squared. right? But if they're both squared and those coefficients are equal, means they're both positive or both negative, then you know you're going to have a circle. Okay. Now, by the way, we haven't really talked much about this, but the eccentricity of a circle is 0. Remember, eccentricity is C over A. Well, there is no focus. There is no C on, what's that?
Hey, Dad.
Oh, yeah. Okay. All right. So the eccentricity is 0 because C over A, there's no C. A would be R. A would be a radius. Okay. A would be the radius, and C, there is no focus. Remember, as it gets more like a circle, the focus goes in closer and closer and closer to the center. And when it becomes a circle, the C is at the center. So there is no C. It's 0. Okay. So not a big deal, but it, could come up maybe if I ask some sort of true-false questions or something like that. I think you can figure that out. Because we have talked about eccentricity on these a little bit. But A and C have opposite signs in a hyperbola, right? So A and C are the ones you're really looking at, the x squared and the y squared. If they're opposite signs, you know it's hyperbola. If A and C have the same sign but they're not equal, then it's an ellipse. They have the same sign. They're both negative. Once you divide out, they'll both end up being positive, okay? And so you know you have an ellipse. And then if one of them is 0, so if there isn't an x squared term or there isn't a y squared term, but there is the other one, that's when you know you have a parabola. And by the way, the eccentricity on a parabola is 1. And we'll talk about that a little more here in a second. But and then if B is not 0, if B is 0, it's not even in there, right? If it's not 0, that means you have an xy term, and that just means it's a rotating term. Okay? All right, now, the one thing you might look back in your notes at is the definitions, okay? Because I might ask you to write a definition. I'm not going to ask you to write all of them, but I might ask you to write 1 or 2. They don't have to be word for word, okay? They all kind of start the same, set of all points, okay? A circle, set of all points equidistant from a given point, or set of all points that are the same distance from the center, something like that, which is the radius, of course. I think you've got those written down somewhere, but if you want to jot that down now, you can. That's okay. But, I think for the most part you can come up with those. And, of course, the standard form of a circle, okay, we should be comfortable with. And the whole completing the square thing is something we do quite a bit of. Okay. And I'm recording this, so if you want to go back and see any of this stuff, you can easy enough. Okay? Set of all points equidistant from a given point. And you don't even have to put the word center in there. Set of all points equidistant. Okay? All right. And that's pretty much all there is with a circle. Like we said, the eccentricity is 0 because the focus, there is no C, right? There is no focus. As they get more circular, ellipses get more and more circular, the focus gets closer and closer and closer to the center, and when it becomes a circle, it is actually there. So A would be like the radius, so it's just Z. Okay? All right. A parabola. Set of all points equidistant from a fixed point and a given line, which is your focus and your directrix. Now, you could just say set of all points equidistant from the focus and the directrix. I'd be fine if you just said that. But it's a set of all points from a fixed point and a given line, or a given point and a given line, fixed point, fixed line, whatever. Right? Now, why is the eccentricity 1? What would C be in this problem? What distance on there would be C, you suppose? Well, it's the same as A, right? Which distance, what is C in an ellipse and a hyperbola? It's a distance to where? The focus, right? Well, what distance in here goes to the focus? P, right? And then the A would be like that distance. I mean, the set of all points that are equidistant from those two places. So the C and the A essentially are the same thing. They're essentially the same thing. And so that's why it's 1. Okay? So we don't call it C, we don't call it A on a parabola, but that's essentially what it is. Okay? So it's they're the same. That's basically the P. It's like P divided by P, basically is what that would be. Okay, and that's why the eccentricity on that is 1. I've got a picture here. See, if I drag this, so if, remember we said the eccentricity on an ellipse was between 0 and 1, right? If it's close to a circle, it's down here near 0, because remember C is, in a circle, C is 0. So it's pretty circular. C is a pretty small value. It's not very far to the focus. But as the focus gets farther away from the center, then C, remember this distance is C, and then this distance is A out to here. All of a sudden the focus and A get real close together, so C and A are almost the same thing. So C divided by A becomes almost 1. But then as soon as it actually is 1, see how that's getting, see what's happening down the ellipse? Okay, and then when it becomes 1, all of a sudden you got a parabola. And then when it gets greater than 1, now you got a hyperbola. Because now C, right, and A, C is always bigger than A, right, in a hyperbola, because the focus is farther away. Remember, this is C. C is from here up to here. Now, it's in the middle here, up to here, and then A is to there. So C is bigger. Okay? So just not a big deal, but just for information. And then, of course, here's our standard form. If it's negative, it goes down. If it's positive, it goes up. But so a normal up and down type parabola is x squared, or just remember y equals x squared is your normal basic parabola you learned about in Algebra 2. And then, so if it's sideways, it's got to be the other way. It's got to be the y squared. It's got to be the y squared. Okay? And so that was your standard form parabolas. Then we had the ellipse. The ellipse was a set of all points in a plane. You don't have to say in a plane. The sum of whose distances is a constant. So ellipse and hyperbola definitions are almost identical, except the words sum and difference. Sum and difference. A set of all points, the sum of whose distances from 2 fixed points, which is your foci, is a constant. Okay? So that distance, those 2 distances added together is a constant for that ellipse. And it's 2a. Remember that constant is 2a. So those 2 things added together is 2a. Okay? That's what that sum is. I'm going to write that in. And then for hyperbola, you just take that and you put the word difference in there. And you got a hyperbola. Okay, so there's going to be plenty of basic questions like what you've been working on and identifying what they are. But there might be a couple in there about what's the definition or something with eccentricity or something, but not not a lot. All right, so ellipse. I don't think we need to go through all that, but those because we just got done with that quiz. But your basic equations. Of those, we talked about the eccentricities between 0 and 1. A is always bigger than B in an ellipse. Then hyperbola, set of all points. The difference whose distances from 2 distinct points is a positive constant. I think in the other one I didn't say positive constant. I just said it's a constant. That kind of goes without saying. Again, this is 2a. The difference between those distances is 2a. And then your basic definitions. And here it matters which one comes first, right? Because the minus sign, the one that comes first matters. A is always the one that's first. And which one it's under tells you which way it goes. So if the x comes first, if the a is under here, you're going to go that way on the x. And that's the way the hyperbola opens. Okay? If the bigger one is the y, or not the bigger one, if the first one is the y, that's the a. And of course all that's on the gold sheet, all those equations. Okay? And that is really all I got. That's pretty much it. Okay? All right. So, give you this one here. And we're going to spend the rest of the time and after lunch working on this and IXLs. Like I said, I've got another got the answers to this up here. I've got another worksheet with just similar stuff on it, which is totally up to you if you want to take it or not. Let's see, I'll put that one there. This other one, which I'll put right here, I've got the answer to yesterday's if you want to check those. And I'll put the answers to these two worksheets up here. If you want to check any of your stuff. Somewhere I've got the answers. Steal my answers. Steal my answers. And then here, your asymptotes, this would be 1 over 2. So it'd be 2 over 1. You have 4. And then this is 7. And I didn't see any work here, but this would be your center. This would be your focus, and that's a distance of 4. So that's C is 4. So it's C squared equals A squared plus B squared, right? So C is 4, so that'd be 16. And then B is 3. So I think you maybe just stuck them 4. Because now it would be A squared equals 7. So that should be a 7. Okay, makes sense? And then that's an ellipse, or that's a circle, since those two are the same coefficients. Okay. So that was Probably won't do much review beforehand. So I will be here in the morning if you've got any questions. Just because I want to make sure we got enough time for everybody. So.